So now we're going to look at how to solve an exponential equation where we cannot get them to match their bases. So we're going to have to use logs to help us out. And and you'll see the reason why here in just a second. So what we're going to do first is we're going to isolate our exponential expression that has the variable up in the exponent. We're then going to take log on both sides. You will then simplify using a power rule or log properties. We'll take a look at a couple of these. And then we're going to solve for a variable. Now, we're going to be looking at several of these, and I'm really going to split them up across a couple of videos. It doesn't get super lengthy. So we are going to take a look at variables with the exponent on one side. Okay, so that'll be one of them. Bases that work well with logs, so things where common log or natural log will come in nice and handy. We'll talk about solving an exponential equation, which is where you need to do a couple of few steps maybe before you get to the point where it looks kind of like what we've been doing. And then in the next video, I'll do one of these variable exponents on both sides and this quadratic looking one. So I'm going to split this up into a couple of videos. So first one that we've got, kind of to get us going. We got 5 to the x equals 134. So now you may be looking at that going, well, that looks simple enough. And it does. The concern that comes up here, okay, is that I cannot get to a power of 5 that is 134. So if we think about our powers of 5, 5 squared is 25, 5 cubed is 125, and then 5 to the 4th is 625. So I bypass over this 134. So we're going to have to use something else. So with this one, okay, one of the things that we notice is we would really like to get the x down out of the exponent. Well, I can't do that in its current format, but I start to think, we did have that rule, the power rule from logs, that said if I had log of something with a power, I could bring that power down out of the exponent. Well, that would be great, except I don't have log. Remember, though, that log is an operation. Same way that you divide both sides or take square root, you can take the log on both sides. So what we can now do is I can take log on both sides like this. Okay? And now on this side, I can bring the x down in front. And remember that that turns into just a multiplication problem. Now then, log 5, we can put that on our calculator. It is just a number value, which means we are allowed to divide it off. Okay, so those two cancel. So now I have log 134 divided by log 5. Now, number one, you do not get to cross the word log off. That is not the way this works, okay? You have to take the log of 134 and then the log of 5 and then do division. We saw this kind of similar when we saw the change of base stuff that came out of section 4.3. Now, this is called an exact answer. Okay, so if they ask you to do something with an exact answer, they are looking to have the word log, whether it is common log like I've done here, or natural log, or any of our other log bases. That is what we're looking at. Now, if, okay, you were asked to do a decimal approximation, that is going to be where you actually pull that onto a calculator. So if I pull up my graphing calculator here, I can do log of 134. Remember that you do need to close that set of parentheses. And then I'm going to do divide log 5. And again, I'm going to close that set of parentheses. And so I get that x is 3.043. I'm going to round at 2. Now, this an approximate answer. Because as you saw on my calculator, I did do some rounding. And so it is not as precise or exact as it is when I leave it in the one that has the word log on it. Okay, so you may be asked to do an exact answer, you may be asked to do an approximate answer. So those are your options. Now, let's take a look at some ones which were in that second type, which is stuff that works well, or bases that work well with log. So, for example, if I have 10 to the x equals 8,000, we are generally only going to use two logs. We're either going to use natural log, which we know has a base of e, or we're going to use common log that has a base of 10. Well, we've got base 10 here. We want to use common log with this. So I'm going to do log 10 to the x equals log 8,000. And if you remember from our stuff, when you have a log with a base, remember that this invisible base is 10. Against this, it crosses off, and it leaves me just the x, or whatever's up here in the exponent. So I now have x by itself. That is our exact answer. I can then put that on a calculator. And I can get x equals 3.9031. And that's going to be our approximate answer. Okay, so we had, here was our exact where we left the word log in it. When I put it on a calculator and went to a decimal number, that is going to be our approximate answer. Now, I'm going to do the next one, which was an exponential equation. Okay, and it's not that we haven't been solving exponential equations. What I mean here is you may have to do a little bit of work before you actually get to the point where you can do that, take the log on both sides. Okay, so I notice here I've got e and it's to the 0.6x. If this is where my variable is, okay, so if I were to kind of cover that piece up and I had 40 marker minus 3 and I was trying to solve for marker here, then the first thing would be add 3 and clear that off as if this were a regular equation. And so this is where, and I'm going to change this to just 0.6. That's going to be 240. Okay. And then we're going to divide, because again, this exponent part is only connected to the e. The 40 is just a coefficient. So I can divide that. So this is now 6. Now, this is another instance where we have certain logs work well. I have a base of e here. That means I want to use natural log. Remember, I do mine in script, okay? 0.6x, natural log of 6, okay? So again, kind of what we saw in that previous one, when you have the log with the matching base against it, those go away. So I have 0.6x, natural log of 6, divide by 0.6, natural log of 6 divided by 0.6. And again, there is my exact. And then if I want my decimal approximation, I'm going to do natural log of 6, make sure I close that, divide by 0.6, and I get that x is 2.9863. And that'll be my approximate answer for that one. Okay? And again, you can always go back in and plug this approximate in. If you do plug the approximate back in up here at the beginning, know that because this answer was rounded down here, you may not get spot on 237. You may get something like 236.99. You may get 237.12. You may get something that's kind of close, but it's because we didn't use the full on decimal down here because we did round this after 4.